This is Mr. Martin. These are video notes for Pre-Calc Advanced, Unit 6. This is video 2, talking about graphing sine and cosine. So in the previous video, we looked at the very basic graphs for sine x and cosine x, and how for sine x, we were graphing the y-coordinate as we go around the unit circle against the angle. And for cosine, we're graphing the x-coordinate as we go around the unit circle. So let's just review our standard forms here. So we've got f of x is equal to d plus a sine bx minus c, or we've got f of x is equal to d plus a cosine bx minus c. And a couple things I mentioned in the last video, this d could be in either the front or the back. Typically I like to write it in the front, but it could easily be added or subtracted if it's a vertical shift down to the back. And when we get to the other trig functions, we're going to use these same standard forms. We'll just substitute out sine or cosine for tangent or cotangent or secant or cosecant. So there's our standard forms, and we have these different letters in there, A, B, C, and D, and these are going to help us find different parts of the graph. So the first thing we want to talk about is the amplitude. Basically, this is half the distance from the maximum values to the minimum values. Alright, so in our other examples that we did in the previous video, the highest value was 1 and the lowest value was -1. That's a distance of 2, so our amplitude was half of that, it's 1. So when we're looking for amplitude, we're going to use our standard form to help us. It's always going to be the absolute value of A. So this value in the front here, in front of the sine or the cosine, is going to give us our amplitude. Again, we always want the absolute value. Okay, moving on to the period. This is one cycle of a trig graph. And when we're calculating period for sine and cosine, this isn't going to be how it works for tangent or cotangent, but for sine and cosine, it's going to be the absolute value of 2 pi over b. So again, we're going to go back to our equation that's given to us. We're going to find the value of b, and then 2 pi over b will tell us how often that cycle is going to repeat. Alright, we need phase shift, or you can also think about this as the horizontal shift, so shifting left or right. Shifting left or right. So the phase shift, I'll usually just abbreviate it as PS. This is calculated by taking the value of C and dividing it by the value of B. Alright, and then a little preview here, a little note for when we're graphing. This value is important when we graph. Okay, so in order to get an accurate cycle, we want to make sure that we're starting at an appropriate value so that we don't get half of a cycle or 3/4 of a cycle. Alright, so that's where this phase shift value is going to come in handy for us. Alright, then we have vertical shift, that's up and down, and this is simply calculated by using the value of d. So d will tell us how far up and how far down. And then distance between key points. So key points are maximums, minimums, or places halfway between. And these are sometimes called points of inflection. Okay, and you'll learn about that more in calculus. All right, and I will usually abbreviate this as distance between key points, dBKPs. And again, this is important for us when we're graphing because it's going to help us find easy places to find coordinates to graph. So the way we calculate this is we take our period and divide it by 4. Okay, so we'll talk about all of these as we go through the examples. I'm going to stop this video here. The next video will be the first example. Again, if you had any questions, make sure that you ask them, and feel free to pause and rewind and rewatch as needed, and we'll see you in the next video.